I'm Ian Crossfield. I'm a fifth-year graduate student here in the astronomy department. I study the atmospheres of extrasolar planets, so trying to figure out what we can learn about planets orbiting other stars. Most of the planets we know about around other stars are big, massive, the size and mass of Jupiter, more or less. But we're starting to find smaller and smaller ones. So several of the planets I've been looking at have been what we call these hot Jupiters. They're the size of Jupiter, but they're very close to their stars. They're very hot. So mainly hot Jupiters, but we're starting to study some of these so-called super-Earths, which are things bigger and more massive than Earth, but small enough that they're probably not just a simple gas giant. Most days I spend here in front of my computer analyzing the data that we take from various telescopes around the world. Most of the telescopes we use are in Hawaii, so we get to go there sometimes, but sometimes we can use the internet and control the telescope from right here at UCLA. Initially, the only thing you know about these planets is their mass and their size. So you just know how big it is and how massive it is, how much stuff is in it. But to actually learn what it's made out of, you have to study the atmosphere somehow in more detail. So you can study the absorption of light by different compounds, like something like methane or carbon dioxide absorbs particular colors, particular wavelengths of light. And so if you see less light coming from the system in those wavelengths, that might tell you something about what molecules or atoms are present in the atmosphere. Mainly what we're still finding is how to do this well. Turns out this is really difficult to do from telescopes on the surface of the Earth, because we're trying to study the atmosphere of another planet while we're looking through our own atmosphere. And clouds can drift overhead, or you can, just a little bit of change in in the humidity, how much water is in our atmosphere, can make it very difficult to tell what's going on in this very, very distant system far away. So a lot of what we've been doing is just learning what are the right techniques to use to do this better. In my mind, one of the more fundamental questions is, we live on this planet Earth, and is this unique, normal, rare, typical? Until we can actually find other solar system analogs with Earth-like planets, we really don't know if there's an Earth around every few stars out there, or if there's one Earth-like planet for every million stars. And right now we don't know that at all, but in the next 5 or 10 years that's something we will actually be able to figure out, and that's really going to be exciting to put us and our planet and our solar system in context of the whole galaxy.